Okay, so today we're going to look at finding tangent lines and normal lines given the equation of a curve. So before we do that, we're just going to revise a little bit of derivatives. So we need to differentiate each one of these. Pause the video, have a go at differentiating them. Okay, so let's have a look at our solutions here. So for this first one, we need to find the derivative. This means that dy dx is going to be 5 times 3, 15, x, 5 minus 1, 4. And then the derivative of this linear term is going to be minus 6. So our second one, we want to convert this into index form. We get 2x squared plus 3x to the minus 1. To find the derivative here, differentiate with respect to x. 2 times 2 is 4. X to the 2 minus 1 is 1. So x to the 1, we don't show the 1. 3 times minus 1 gives minus 3. X minus 1 gives minus 2. And then we're going to rewrite that as 4x minus 3 over x squared. Our last term. So the coefficient of this first cubic term is a. That's not an issue for us, so we just leave it as a, and we convert the second term into index form. That's going to give minus 4x to the minus 2. Differentiating now, we get 3 times a is 3a x squared. Minus 2 times minus 4 gives plus 8 x to the minus 3. And then we shall rewrite that as 3ax squared plus 8 over x cubed. That's the extent of the derivatives that we need to know. Okay, so what is a tangent line? What is a normal line? You see here in this diagram, the curve is drawn in black. We have this curve drawn here. And we're looking at finding the tangent line at this particular point of tangency, which is marked here in the center. So the tangent line is this red line here. Notice it's touching the curve once, and then it passes through. That green line is actually a normal line. I seem to have messed up the scaling on it, which makes it look like it's not quite perpendicular. But this is actually a normal line. It's perpendicular to right angles. I think I've got another diagram here. I've also got the scale wrong there on that one. Oops. One of the difficulties of scaling things wrong. Okay, so the original function, f of x, is going to tell you the y value for any x point. The derivative function is going to tell us the gradient for any x point. So that means we are going to use this with the point slope form. The original function is going to tell you what y1 is. The derivative is going to tell you what the gradient is, and we're told the x value. So we're going to use point slope form in order to find different lines. Key piece of information, super key piece of information here, is that the tangent shares the same slope as the curve at any point. So m, or the gradient of the tangent, is equal to the derivative of the function at that particular point. Now, a normal line is perpendicular to the tangent, which means it has the negative reciprocal gradient. We can also see this as minus 1 over m. That's the gradient of the tangent, is minus 1 over m, which is where m is the gradient of the, the gradient of the normal is minus 1 over the m, where m is the gradient of the tangent. Let's have a go at a question. Given a function, f of x equals 4x minus x squared, find the equation of the tangent and the normal at x equals 1. You have a few steps you need to follow for this one. So first up, First step, number one, is you need to find what y1 is equal to. y1 is equal to f of x1. And this is our x1. It's the point we're interested in. So we're going to put this one into the function. Let's find f of 1, which will give 4 times 1 minus 1 squared, which will give 4 minus 1, which is equal to 3. Next, we need to find the gradient. So the gradient m is equal to f dash of x1, which in our case is f dash of 1. So we need to find the derivative. Let me just do that. If f of x is equal to 4x minus x squared, then the derivative is equal to 4 minus 2x. So let's take that and stick it in up here. We need 4 minus 2x. So 4 minus 2 is 2. So there's our gradient. So lastly, we can build our tangent line, which is using the formula y minus y1 equals m bracket x minus x1. Putting our pieces in, we've got y minus y1, which is 3, m, which is 2, x minus x1, which is 1. This is the gradient of our tangent. Now, if we wish to find the normal, we need to take the gradient of the tangent and find the negative reciprocal. So the gradient for the normal line is minus 1 over the gradient of the tangent, which is minus 1 over 2, which is minus a half. They have the same y value and x value. So putting that now into our formula is going to give y minus 3 is equal to minus a half bracket x minus 1. Essentially, this is what we need to know today, is this process here, how to find the equation of a tangent line and a normal line. So here we see the two graphs. So they're written in point slope form. So let's see if we have the same answers. So converting this first one into point slope form is going to give us y equals 2x minus 2 plus 3, which is y equals 2x plus 1. And doing the normal, we get y equals minus a half x plus a half plus 3, which is minus a half x plus 7 over 2, or minus 0.5x plus 3.5. So 2x plus 1 and half x plus 3. 2x plus 1, a half x, minus half x plus 3. And this is our tangent line where it touches the curve here at one point. This is the point 1, 3. And we see the tangent line and the normal line. The reason it's not looking 90 degrees is I've chosen a different scale here. Notice this length here is 1, whereas this length here is 1. So it's a 2-to-1 scale. That distorts how the graph is looking and messes with our graph from looking like it's a tangent line. It's a normal line. It is 90 degrees. It's just the scale is different. Okay, these are past paper style questions that will help us prepare for the quiz. So consider the function, find f prime of x. So this symbol here that we're seeing here today is another way of writing the derivative. This means the derivative of y with respect to x, so to speak. So we've got the function f, so this is in function notation, f, that little dash, so we can say f dash of x or f prime of x. So for a, we are required to find the derivative of our function. So f prime of x is going to be 1/3 times 3x squared plus 3/4 times 2x minus 1. Simplifying that, we get x squared plus 3/2x minus 1. Find the gradient of the graph y equals f of x at the point x equals 2. So our gradient is equal to f prime of 2, which means we put a 2 in here. We put a 2 in there. This 2 cancels that 2. We get 4 plus 3 minus 1, which equals 6. Find the equation of the tangent line to the graph at x equals 2. Give it in general form, ax plus, all right. So we need all our bits and pieces. Our formula is y minus y1 is equal to m bracket x minus x1. We've got most of this calculated. Do we have the y value? No, we don't have the y value. So which function do we put it into the y to find the y value? We put it into f of x. So firstly, y1 is equal to f of, and our x value is 2. So we need 1/3 bracket 2 to the power of 3 plus 3/4 2 to the power of 2 minus 2 minus 1. Let's use the calculator for that one. Not a martyr today. 1/3 times 2 cubed plus 3/4 times 2 squared minus 2 minus 1. I'm just double checking and verifying my positive and negative signs. Make sure I'm not messing up. If I'm not, and I get 8/3. So we have our m, and we're fine. So just double, on these type of questions, just double check here. Are we after the tangent line or the normal line? You'll find the questions will flip backwards and forwards between them. Those two, you have to make sure you're getting the right one. So we've got y minus 8/3 is equal to, and our m value is here, m, 6 bracket x minus 2. Now notice it is in general form, which means that all of the constants have to be integers. So take whichever number we have in the denominator here and multiply through by that. It gives us 3y minus 8 is equal to 18 bracket x minus 2. Open the bracket, we get 3y minus 8 is equal to 18x minus 36. And then we have to move it all over onto one side. So we've got minus 18x plus 3y. Adding 36 to both sides is going to give us plus 28 equals 0. I always like to make the x positive, but that would be the right answer. Making the x positive, I get the other two negative like this. Just changing all the plus and minus signs. Okay, last question. So let's find the derivative now. I'll do this one a little bit quicker. I'm running out of time. F prime of x is equal to minus 2 over x squared plus 6x. Get a little bit quicker at those reciprocal ones once you've done them a few times. Find the equation of the normal at 1, 2. So we need to find the gradient now. So the gradient is equal to minus 1 over f prime of, is our x value, 1. F prime of 1. So minus 1, so let's find f prime of 1 here. Get minus 2 over 1 plus 6, which is equal to 4. Minus a quarter. So y minus y1, which is 2, that's given to us here, is equal to minus a quarter x minus 1. Multiply through by 4, because we have a 4 down here in the denominator. We have to get rid of that. Goes on to every other term. We get 4y minus 8 is equal to minus x plus 1. Rearranging, we get x plus 4y minus 9 equals 0.